Hi everyone, welcome to my presentation. My name is Hüseyin Avni. I am studying at Department of Industrial Engineering at Karadeniz Technical University in Trabzon. My work is titled as Optimization of Seasonal ANN for Monthly Energy Demand Forecasting of Turkey. In my presentation plan, I will give some information about importance of natural gas and general situation in Turkey. After I speak to the motivation of the work, I will finish the presentation with seasonal ANN, application and conclusion. As you know, natural gas has a vital important status in primary energy sources. The natural gas is used for electricity production, industry and heating, etc. Because Turkey has poor natural gas sources, the demand has been supplied by producer countries. Natural gas demand forecasting is of even more significance for Turkey, which imports 99% of its natural gas consumption. The growth of Turkish economy occurred as 6% on an average annual real GDP growth rate between 2004 and 2017. In the last 2 decades, Turkey has made significant progress. In 2017, Turkey's population reached 81 million with an increase of 25% according to the year of 2000. In the same way, annual natural gas consumption reached about 54 billion meter cube with an increase of 283%. Most of the studies of demand forecasting in the literature is performed annually. However, seasonal demand for natural gas cannot be foreseen through annual studies. The aim of these studies is to forecast the monthly Turkey's natural gas demand. Because it has been studied with monthly data showing seasonality, seasonal ANN which can make successful projection in the literature has been preferred. Artificial neural networks are the generalization of the mathematical model of human cognition and biological neurons. It's provided that the network learns the relationship between the input-output variables by giving the input and output information to the network. ANN has reached successful results in the forecasting problems based on time series. You can see the general structure of seasonal ANN. The inputs of ANN for time series forecasting consist of past observation values of data. The output also represents the prediction value of future. The nonlinear relation modeled by ANN can be written as a function of past observation as below. Here there are pseudocode of optimized seasonal ANN. Firstly, create n times as dimensional data set in training set. Then define m times as education data set. K is equal to 1. In while cycle, K is less than or equal to n minus n. In for cycle, number of neurons is from 1 to 15. For training algorithm activation function, all combination is running. Select training algorithm. Select activation function in hidden layer. Select activation function in output layer. Apply ANN for training and test set. Then hold key all parameters and performance measure and for cycle. Then increase 1 to key and while cycle. Determine best key and all parameters according to performance measure. Forecast monthly energy demand according to optimized seasonal ANN. Then stop the pseudocode. You can see here the used data. 18 years, namely 216 months data were used. The last 4 years were used for the test set. The rest were utilized for the training set. As seen in the figure, the data has seasonality and growing trend. In order to evaluate the result, mean absolute error, root mean square error, and mean absolute percentage error were used. You can see here the formulation of them. When run the proposed approach, K was found 9. There were 9 inputs and 1 output in ANN structure, and 6 hidden neurons were used in the hidden layer. As a learning algorithm, gradient descent with adaptive learning rate backpropagation algorithm was used. These parameters were determined by optimized seasonal ANN described in the pseudocode. In order to compare the result of ANN, Saruma, which is a traditional method for time series, is considered. In order to adjust the parameters of Saruma model, the plot of the natural gas time series, autocorrelation and partial autocorrelation function of the series were used. The parameters of the model were estimated by maximum likelihood. The generated model was Saruma 110 times 110 prime 12. The graph of the residuals of fitted model were given in figure. A good fitting was captured according to graph. The determined coefficient of the model were as below. T and P values indicate the significance of the coefficient. As shown below, the results were obtained for training and test sets. Although Saruma performed better in training set, seasonal ANN had more successful result in the test set. You can see clearly in that figure, seasonal ANN is closer to actual values. Here there are the forecasting values obtained by seasonal ANN until 2023. Of the forecasting values, The forecasting values have seasonality and growing trend like the dataset. Consequently, in this study, the natural gas demand of Turkey was forecasted until 2023 on monthly base. Seasonal ANN considered number of past periods was used in order to improve forecasting success. Besides, the performance of seasonal ANN was compared with the traditional seasonal time series forecasting model that called Sarıma. The obtained result have shown the superiority of the seasonal ANN. Monthly natural gas demand forecasting was not studied widely in the literature. This study meets an important need for 2023 medium-term program of Turkey. It is an example of monthly forecasting based on seasonal ANN. Forecasting of monthly gas demand may help governments to develop the storage and maintenance policies. For attention, see you next time.